Hello and welcome. Today, we're going to decode a seriously powerful tool for making the best possible decisions when you just can't have it all. It's called linear programming, and trust me, it's a total game changer.
Think about it for a second. Every single day, whether you're running a massive company or, heck, just planning your weekly meals, you're facing this exact problem. You've got a limited amount of time, money, materials, whatever it is. So, with all the different choices you could make, how in the world do you find that single best one?
And that right there, that's what we call the optimizer's dilemma. It's this constant puzzle of trying to get the absolute best outcome when your hands are tied by all these real-world limits. Okay, let's make this super concrete. Picture this. You run a small food company, you've got exactly 100 gallons of vegetable oil and 42 bags of flour in your pantry. That's it. You can make two things, buffalo and spring rolls. So the million-dollar question is, how many of each should you make to walk away with the most profit possible? It's not something you can just eyeball, right?
Well, what if I told you there's a mathematical method that's literally designed to solve this exact kind of puzzle? A way to take all the guesswork out of it and replace it with a crystal clear, data-driven answer. That method is linear programming. And honestly, you can think of it like a secret weapon for making smart decisions. It's all about translating your messy, real-world problem into a clean mathematical model that a computer can solve to find the perfect solution, whether that's the highest profit, the lowest cost, or the most efficient way to do something. Now, the best part is, no matter how complicated the problem looks on the surface, it's always, and I mean always, built from just three simple core ingredients. Once you get these three down, you can basically model anything. Seriously, any linear programming problem you'll ever see, no matter how big or small, just boils down to these three questions. What are you trying to decide? What's your ultimate goal? And what are the rules you have to play by?
First up, your decision. In the world of LP, we call these things decision variables. They're basically just the answers we're looking for. The map legend analogy here is perfect. Instead of writing out the number of spring rolls to produce over and over again, we just use a simple symbol, like X2. It's a shorthand, just like seeing a little church symbol on a map is way easier than reading the words place of worship.
All right, number two, your goal. This is what's called the objective function. It sounds fancy, but it's really just a simple mathematical sentence that says exactly what you're trying to do. Are you trying to maximize something, like shoot for the moon, or minimize something, like keep your costs on the ground?
And really, your goal is pretty much always going to fall into one of those two buckets. You're either trying to maximize something good, like your profit, or you're trying to minimize something bad, like your costs or waste. Simple as that.
And that brings us to our final and maybe most important ingredient, your limits. In LP speak, we call them constraints. These are the rules of the game, the reality check. You don't have infinite money. You don't have endless supplies. This step is absolutely crucial because it keeps your whole plan grounded in the real world.
Okay, so enough theory. Let's actually see how this works. We're going to take those three ingredients, our decision, our goal, and our limits, and apply them to our food company problem. We're going to build the perfect plan.
All right, so here's a quick recap of the situation. We've got our two products, buffalo and spring rolls. Our goal is clear, maximize profit. We know we make $6 for every buffalo and $4 for every spring roll. And we know our hard limits, 100 gallons of oil and 42 bags of flour.
Step one, super easy. We've got to define our decision variables. What are the two things we need to decide? Well, how many buffalo to make and how many spring rolls to make. So let's just say X1 is the number of buffalo and X2 is the number of spring rolls. Done. Next up, step two, state our goal. We want to maximize our total profit. Let's just call our profit Z. So how do we calculate that? Well, we get $6 for every X1 we sell and $4 for every X2. So our total profit Z is just 6 times X1 plus 4 times X2. That's our objective function.
Okay, now for the really crucial part. Step 3. We've got to define our limits. This is where we take our real-world shortages, that limited oil and flour, and turn them into mathematical rules that our plan has to follow. No exceptions.
So let's break this down. Take the vegetable oil. Let's say it takes 10 gallons to make one buffalo and 10 gallons to make one spring roll. So the total oil we use, that's 10 times X1 plus 10 times X2, has to be less than or equal to the 100 gallons we have. We can't use more than we've got. Same logic for the flour. If buffalo takes 7 bags and spring rolls take 3, then 7 times X1 plus 3 times X2 can't be more than our 42 available bags. See, it's just a logical statement.
And there's one last little rule we always have to add. It's kind of the common sense rule, the non-negativity constraint. All it says is that x1 and x2 have to be 0 or more. Why? Well, because you can't make -5 spring rolls, right? It just keeps our final answer based in reality.
So, after all that, after defining our decision, our goal, and all our limits, we can finally put all the pieces together. We can create one single, clean, elegant model.
And there it is. Look at that. This is our final blueprint. We want to maximize our profit Z subject to our oil constraint, our flour constraint, and our common sense constraint. We've just successfully translated a messy, real-world business problem into a beautifully clear mathematical language. And you know what's so cool about this? The hard part? It's over. We did it. All we have to do now is hand this blueprint over to a computer or a piece of software. It'll crunch the numbers in an instant and tell us the exact values for x1 and x2, the perfect number of buffalo and spring rolls to make for the most profit possible.
So why should you care about any of this? Why does this all matter? Well, it really boils down to 3 huge things. 1, it lets you turn a chaotic, complex problem into a clear, actionable plan. 2, it gets you to make decisions based on actual data, not just a gut feeling. And 3, it guarantees you are squeezing every last drop of value out of the limited resources you have.
And look, this is not just for some big company making spring rolls. You could use this to figure out the best investment portfolio, to create the most efficient work schedule, or to plan a delivery route. The applications are endless. So I'll leave you with this question. What's one complex decision in your world that this kind of blueprint could help you